From the first part of this video, you'll remember the demo application which uses a grid control and a custom store to read data from a MongoDB backend. That part of the demo implemented the read side of a service-based application system, as it's described by the CQRS pattern. To complete the picture, I will now add a write side implementation using additional services to apply data updates and providing UI functionality so an end user can make changes. First, I'll add a service that implements two endpoints for updates to specific fields of the data source. The two endpoints are separate for illustrative purposes. In a distributed application system, the CQRS write side can implement any number of parallel data update paths based on business logic requirements. In the sample project, the new service is now included in the Docker Compose configuration file with the name Base Data Write Service. The service is written in JavaScript and just one code file is needed. In index.js, you see a few lines near the top to initialize the Express web server, and then individual blocks at the bottom to accept incoming requests for the two endpoints which were mentioned in the diagram. In each case, the endpoint only accepts the fields it is responsible for and runs an update for the MongoDB data. Note that these are placeholder implementations. The point is that your server-side code can have any complexity you require, and it can handle different business logic data models independently. In the React front-end project, the data grid control has been configured all along to support editing. You can see the editing feature enabled in code and the configuration of the editing form. The custom data store implementation is the same as in the first video, but now I will add code to the update function. This function is called automatically by the data grid if the user edited data and now wants to persist the changes. The code checks whether any of the two fields, task subject and task priority, are included in the values object, which indicates that they have been changed by the user. If so, a fetch promise is returned, which passes the changed values to an endpoint of the base data write service. The demo application system runs in Docker now. You can see the 4 containers in the process list. I run a command to follow the log output from the service container so we can check in a moment that the service has been called. In the browser, the application appears as before. In the first video, I ignored the edit button in the leftmost column, but now I click it and the edit form appears. I change the subject and priority fields and then click Save. The grid shows the updated value correctly because it retains the changes on the client side automatically if the save operation completes successfully. A quick look at the console window confirms the service has been called, a put request with a specific task ID. In the browser, I reload the page and the changed row appears correctly after it has been reloaded from the server. The update logic works correctly. For the second endpoint offered by the base data service, I have now added a second block of code to the update function. In the example, this code works exactly like the first block. If the relevant fields are affected by the update, the service is contacted. Both update operation promises are combined on return. To complete the picture for a service-based CQRS application architecture, I will now add a second service to the sample project. This is called the completion write service, since it handles the completion state of the task objects. This service will use C# and .NET instead of JavaScript, and I will add an explicit call interface to the data grid in addition to the automatic editing functionality with the custom store that you have seen so far. Like before, I added the new service to the Docker Compose setup. The project is a simple ASP.NET Core Web API service, which uses the MongoDB driver to interface with the database just like the JavaScript service. The function setCompletionAsync changes the field task completion for the given task ID. And in the controller, the two endpoints are implemented with different URL patterns. Once more, this is example code. The point is that any number of services and endpoints can live side by side with varying implementation complexity. To use the new service functionality in the front-end app, I've already added another block to the update function, which creates a third promise to change the completion value as necessary. The approach is the same as before, only now the update function potentially calls into 3 different endpoints and 2 different services. Of course, I don't recommend introducing such complexity needlessly, but service structures and real application systems can easily grow to this point. As a final step, I'll now add a data persistence feature that is independent of the custom store-based functionality you've seen so far. First, I add a custom button to the grid column that already displays the standard edit button. You can see that the button expects 2 functions, mark done and mark done disabled, and I add these to the top of the component function now. Mark done disabled simply checks whether the button can be activated because the completion value is not 100% yet. Mark done is where the service update functionality is called, using a fetch call like before. Since this event handler bypasses the built-in editing functionality of the data grid, I implement custom optimistic update logic to follow the service call. The client-side value is set to 100 under the assumption that the server has successfully applied the same change. With all the changes in place, I edit a row in the browser again. I change the subject and priority fields as before. Then I also set the due date and I set the completion to 99 so that the change is recognizable. I save and the grid reflects all the updates correctly. I reload the page and the server-side data is also correct. Now I click the new Mark Done button. The row immediately reflects the 100% completion state, and this is also reloaded correctly from the server. Here's a summary of the steps I demonstrated in these 2 videos. First, I bound the grid to the MongoDB specific read service using the adapter library DevExtreme query MongoDB. I implemented a custom store for the data grid that accepts runtime options and calls the read service. Second, I added editing features to the system by including data modification services. I implemented these services using JavaScript and C#, and I added a total of 4 endpoints to illustrate the flexibility offered by a distributed system. On the client side, I demonstrated how the editing functionality can be tied to the custom store and how it can be used independently. And that's it for this video. If you enjoyed it, please give us a thumbs up. If you have any questions, please comment below. And don't forget to subscribe and ring that bell so you get notified whenever we release new content. Thanks for watching, and thank you for choosing DevExpress.